Hello. In this video, we are going to answer most important question on multiple integrals. Previously, we have defined what is multiple integrals, but in this video, we are again going to explore those things, and we will take simple problems and try to see that how to do the multiple integrals, and we are also going to talk about that where these multiple integrals is occurring in physics and different branch of things, and how we can solve the IIT JAM problems. So this is Saddam and AutoCAD. Let's get started. When we are doing the multiple integrals, the main concept is that you have some function which has dependency in x and y, and we are trying to find this integral in both x and y domain, and therefore we have to use not one integral, rather than we have to use two integrals. In my previous videos, I have already given you that how to find the limits, and the limits of where you have both the functions, the function is depending on both the variables, and if this function is continuous at these limits, then and only we can evaluate the derivative of this function, and if this function is continuous, the limit exists, then and only then we can evaluate this type of integrals. So the first condition to evaluate this particular integral is that the assumption that it must be continuous in particular domain. Now, when we are talking about the particular domain, it means that we are going to take the limits, because these limits are definite type of integrals. So if I am writing this thing like integral f of x comma y dx dy, what it suggests that it's suggesting that you are first doing the integral with x by assuming that your y is constant. Now once you have done this integral, then you can explore the other integral depending on the y variable. On the other hand, we can also do this thing, like this is not a very hard and fast rule that you have to adopt. You have to always write dx comma dx into dy. You can also use dy comma dx, dy times dx. And in this case, we have to first evaluate the integral in dy domain, and then we can find the integral in dx. So in this regard, we will first try to define how to define the limits. So the limits are, that if everything is, so the limits in usual way can be defined like this: f of x comma y, and suppose I have dy and dx. So first I am saying that we are going to take dy f of x comma y dy. So therefore, in this sense, our x is constant and y is a variable. Therefore, the limits will depend on that y is equal to, let us say, something of g1x and y is equal to something of g2x. Now, once you will do the integral, your x is constant, then you have to put these limits and you will evaluate this integral, and everything will become in x. And now, when you find this, then you will end up with x integral, and you have to have following limits like a and b. Now this is very general. Now here we have considered that y is equal to g1 of x and y is equal to g2 of x. Where this is emerging in the topic, this kind of integral can be seen where you have the region at which you want to find the area, because these are called the area integral. So the region must be something like non-rectangular. So the non-rectangular region can be like of ellipse, maybe some different type of shape, or maybe let us say some integral, or maybe some curve. So whenever we try to find out this particular type of areas, then we have to use the multiple integral concept like this. And in this case, if you have any kind of function which is defining this thing, then where you do the first integral, this first integral's limit is depending on the other variable. Now this integral is not hard and fast rule, because that I have already said that you can exchange those variables. And how you can do this exchange of variables? And this exchange of variables means that you can switch this thing dy and dx. Now once you will switch these positions, it means that you have to first do the integral what is over here. This is the first one, and then you have to do the second one. Now, depending on the way you choose it, the way you choose dy and dx to be first and second, your limits would change. And similarly, the limits will affect it like this. So the first type of thing that I have f of x comma y dy and dx, this is the integral limit. In the second type, if I want to calculate the same function, the function would be same, f of x comma y. Instead of my x constant, I can take x constant, I can take that x is my variable, now y is constant. I am gonna use over here that, okay, here I will have, let us say, h1 of y, and this limit is h2 of y. Now, once you have done this thing, then you can take the integral, whatever you have got it, and you can evaluate this limit on this one, c comma d. It means that these integrals that you have already seen here, that these integrals have completely changed c and t. Now, how we can think of these type of changes, I'm going to explain you in a minute by using some examples. What I am very much interested here, that how we can do the simple thing. For an example, now I have already told you that these kind of integrals that appear where the integral is not constant, that the sub-integral is not constant, these kind of integrals appear when you have very complicated kind of a structure. For an example, ellipse or maybe some kind of thing. But suppose that you have a rectangular kind of a structure. For an example, something is perfectly rectangular. So you have from here to here is already the length is already determined. On the other hand, here your y is already determined, let us say b and so on. So let us say it is a to b, and maybe here it is b to c or c to d, whatever it can say. In some sense, these are already perfectly constant. So I can write here that a is equal to this kind of thing. We can say that dx, and here this is a dy. I can write f of x comma y, let us say dx dy, and for here x it would be, let us say, a comma b, and y would be c comma d. Okay, now you don't have to worry about that what is who will I took care first, because these limits are constant where a, b, c comma d are constant. So now if you change the positions of this integral, let us say c comma d or a comma b, it won't going to affect anything. Okay, so this is a very important aspect. This is a very important concept. So if somebody has already given you these limits are constant, means that you are evaluating the integral in a rectangular space, in the rectangular region, then by switching these variables, it won't affect the integral or integral limits. However, if the region is non-rectangular, it means that your y or x are dependent on each other, then it will, your limits will gonna change how you wanna select your dy comma dx, dy and dx region. Understood? So this point is very much important. So first, a very simple example that I am going to use over here, that I have 0 comma 2, and let's say I have minus 1 comma 1, and there is something x minus y, and I got dy times dx. Now here you can say that, okay, I'm going to evaluate this integral first, and mind it that for this one, this integral is, so let us say this is 0 to 1 to minus 1 to 1, and if I am using this evaluation of this integral, it means that x is constant, so you have to treat x as a constant. So what I have done here, that I'm going to take the integral of x minus y dy. So x is constant, therefore dy, integral of dy is y, and for this one the integral will be y square by 2, and I'm going to put the limit over here minus 1 to 1, and then I'm going to multiply dx. Okay, so now what you will find that whenever you have, for here the integration variable is y. So when you are putting the integration limits, you have to know that what is your integration variable. So I am going to replace those limit by that integration variable, not the x. Okay, so mind it. So here I can put that x times 1 minus this one, x times minus of 1. This one integral is complete. Now another integral is half. Y square is 1 and minus of 1 square is 1 again, and then dx. So this integral will vanish away, and I got 0 to 2 x and this would be plus x times dx, and here you have 2x, so I can write here 2x square by 2, and limit I'm going to put 0 by 2, 2 to cancel, and I have 4 minus 0 is 4. So this is the answer of this. Now I had told you that when you have limit constant, then if you choose to do the integral by switching these positions, the integral won't be affected. So let me give you the same analogy over here, that is this true or false. Let us just verify at this moment. Now I am not changing the positioning of these limits. Okay, so first I am going to do evaluate this integral, and what I can do that x square by 2 minus yx, I'm going to put limit minus 1 to 1 dy over here. So what I'm going to do, replace everything by 1, so I can just write 1 minus 1 by 2. Okay, and over here this is y, x would be like 1 minus, and yeah, minus of 1, and then dy. So you see that this is going to vanish away. Minus 2y, 0 to 2, minus 2y, minus plus, and dy integral 0 to 2 y square by 2 into 2 with negative sign 0 to 2, and the answer would be, oh my god, the answer is 4. But why is that? This integral is caring about this one, okay, and this integral is carrying this one. So when you are exchanging the position, then you have to see that where is your limit. You have to replace this thing. For an example, when you are exchanging the limits, what you need to do, what you are required to do is that, let us say ab f of x comma y, and you have done dx, and there is dy, let us say c comma d. This will be equal to, if you are exchanging these two positions, then you have to select fx comma y, since this is y is equal to c and y is equal to d, x is equal to a, x is equal to b. Okay, so this was my bad. Fx comma y, now I am exchanging this one, so this will follow these limits, therefore it has to be c comma d, and over here you got dx, and which is gonna follow these two limits. So when you are exchanging these things, depending on the limits that you have, although they are constants, because now since you are integrating, you are following that path, understood? So you are integrating this in x direction, and you are integrating then y direction. So whenever you exchange those positions, you have also shift those integrals, isn't it? So now what you can do over here for this type of problem, what I written that 0 to 2 minus 1 to 1 x minus of y dy times dx. Now what you can do is that I can simply say that minus 1 to 1 over here, 0 to 2 over here. Now since 0 to 2 is taking the integral dx, and then I'm going to do this dy. So here I can just simply say that minus 1 to 1 x square by 2, which is 4 by 2, okay, and it will be 0, and yx would be 2, and then here it is 2, and dy, what's going on, this has to be 2y. So now I can write that 2 minus y, therefore this will be like 2 minus 2y into dy. So here I will get 2y minus y square, because y square over 2 to cancel out, and therefore I'm going to take 1 to 1. So 2 becomes 1 minus of minus 1, and since it is y square, therefore this will become 0. Therefore 2 times 2 is 4. Yes. So now you understood perfectly that if we have fx comma y, then we have to understand that in which direction you have taken the limit. So these are following the geometry. So you cannot just say that because these are constant, you have to also understand that although they are constant, but they have already perfectly geometrized. We have geometrized it because they are rectangle, they are not square, understood? So this is the case. Now we are going to understand a few more examples of the non-trivial one when the region is non-rectangular one. So what is the question? The question is following. Here is a following problem. Find the volume of prism whose base is the triangle in xy plane bounded by x-axis and the line y is equal to x and x is equal to 1. So they are bounded by x-axis. So the thing is that we already understand how the prism looks like. The prism looks like this one, isn't it? We have already done several experiments. So prism has the triangle kind of a structure. Now they have already described that you have the prism whose base is lying in the xy plane, and these xy plane, the prism has boundation, because you have already seen that the boundation is kind of triangle one. So how we can plot this bounded kind of curve? Now we can see that first of all there is a three axes. They have already mentioned the three axes. So here I am going to write over x and y, and they have already seen that y is equal to x. Then y is equal to x means that this is making a 45 degree of angle, okay, with x or y. So this is it, y is equal to x line, and here there is a x is equal to 1. So x is equal to 1 means that you have to take like this, x is equal to 1. So this is, let us say, x is equal to 1. So now you have the following, because it is starting from 0, because y is equal to x, therefore there is a slope of x, and the constant is at 0, okay. So it will pass through x is equal to 0, so y is equal to 0. So this is forming a base. So once it is done, then what is the meaning? The meaning that we have already seen that here there was a triangle, and you can see another triangle is forming like this. So therefore you can see that this particular distance is basically given by z. Z is equal to 3 minus x minus y, and you may see that this is the one of the base and another of the base is over here. It means that this is the completely symmetric one. So what I can do is that I can just also follow that, okay, this is another x and y plane, and I can see that this is another like this. So x is equal to 1 maybe over here, then you can just draw like this, okay. So this is so my drawing is not good, but this is the analogy that we can always use, that this is your x, this is the y, and here y is equal to x line, and this is basically the symmetric one, and we have the length is varying in the space just like given by z. And now you can see that this z is basically depending on what? Fx comma y. So they have said that find the volume. So in order to find the volume, what you are required to do is that you are not required to use the volumetric integral. So these are the bounding curve that it is presenting over here. So in the sense that if you want to find the volume of this curve, volume of this region, what is implying that z is dx into dy. Just like in the one dimension, when you try to find the area under the curve, what is implying? It implies that f of x and times dx. It will give you the region, the area under the curve. Similarly, over here you can see that these are the two areas, and two areas are bounded by something like this. So this z is saying that how this curve or how much there it is. So there is a kind of packet of region, and this packet of region is given by z, and basically this is nothing but f of x comma y. So I can say that the volume is basically f of x comma y dx comma dy. So what we are evaluating the double integrals. So I can write here double integrals. Now instead of volume, then you can say that okay, physically it is a volume, but mathematically you can say this is an area integral, correct? So we have to again say that okay, this is a volume integral. So now I am going to translate this everything, because these are again a symmetric one. So let me just just only stick with x comma y kind of curve. X is y, x is equal to 1 over here, and y is equal to x like this. So this is y is equal to x, and this is x is equal to 1. Now we have what we are required over here. Why required over here is that how the limit is going to vary. Understood? So they have already given you fx comma y dx dy, but how we can choose the limits? Now this is the very interesting problem over here, because here there are two curves. Now you can see that there are two curves which are intersecting over here. So the two curves are y is equal to x and x is equal to 1. Understood? And we understand that if you are writing this thing like this, x dx comma dy, then you have to establish that how the integrals is going to vary. So for an example, if I am writing this integral like this dx dy, what does it imply? It implies that first your y is constant. It means that your limit is x, and you have to write in terms of g of y. Okay, so this is g1 of y, x is equal to g2 of y. This is how we have to write it. Now, when you are trying to evaluate this thing and where y is constant, it means that you are taking the length element or whatever the element in this direction. It means that you are first doing at some constant y, okay, at some y constant. You are first trying to see that how your x is varying, because these are very continuous thing. The area is continuously changing. So you are trying to find the infinitesimal change in the first x direction, and then you're gonna stretch this thing over here to over here and to find the integral in dy element. So in a first video, I have already explained that how we have to take this thing in certain cases. So over here, what we can say that, okay, first we have to try dx. Very good. So now here what we can say that how we can find that which one be lower limit. So if you find the integral in x limit, so you have to always go from left to right. Okay. So now as I have traced over here that this is my left to right. Okay. So therefore this y is equal to x line, because I am taking some kind of infinitesimal over here. Therefore this has the lower limit y is equal to x, because this is the y is equal to x line. And now this integral this line is basically cutting on what? X is equal to 1 line. So I know that this particular line is basically what? 1. So I can simply write over here that inside the integral, if I am going in the x direction, first I am evaluating this x direction, then I have to go, because x is equal to y, so I have to first go x is equal to y and x is equal to 1. This is my first integral, and I had already given 3 minus x minus y, and I'm gonna take the integral first in the direction. And now come to dy. Now once you are done that, what is how the region is varying in the x direction. Now you have to stretch this thing over like this. So how your y is varying, you see that y is going from 0 to, because this is corresponding to what? Is corresponding to 1, isn't it? Because when if x is equal to 1, then what will be y is equal to be also 1. So this is your coordinate, y is equal to 1. So this is how we are going to identify the limit. That how these two curves, which is making some region, how these curves are going to give you the limit. So you have to check that how your x is varying in particular direction and how the y is varying. And you have to also select, because we are assuming that whatever this function is well defined in this bounded region. And I have already described, you have to just stick that, okay, we are trying to find the integral in x and y direction or y or x direction. So which is more convenient, you have to choose. Now when you are doing the dy integration, you can say that, okay, I'm just moving from 0 to 1. So now 0 to 1. So this will give you some particular volume of this particular curve. There is a complete volume of this prism. Understood? Now you may say, now we have already repeated that, okay, I have written this thing like this. Then what if I want to write this in terms of dy, and then I'm going to do the dx. So the thing is that you will get that if I'm writing over here fx comma y, then first I'm going to write dy and dx. I'm going to choose this limits. So these are very important aspects to choose the limits. So now here I'm going to see that this is y is equal to x line, and there is a x is equal to 1 line. Okay, so this is my x is equal to 1 line. I have here 0, and this is my 1, and this is x is equal to 1. So if you do dy integration first, it means that you have to first do the integration. Dy is going in vertical direction, so you have to first change in y direction. So it means that you are going from lower end to upper end, correct? So this is how you have x is fixed and you are going from lower end to upper end, correct? So now when you see that how we have to choose limit, so y is varying. Y is varying from what? Y is varying here, and here y is what? Y is equal to 0, because y is equal to 0, this is the line now. And now as you go upside and you are cutting this y is equal to x line. So here I can say that y is equal to 0 and y is equal to x. So it means that I have to put everywhere x, and then I'm going to take the integral dx. And how the x is varying? X is varying from left to right, because this is the way. So 0 to 1. And this is again give you the volume of the prism. So if you simply find out that what will going to happen this in 3xy, so here I'm going to just evaluate this one, because this is very convenient. 3 of x minus y. First I'm going to take dy and dx, and you will see that 0, 1. First I'm going to evaluate 3y minus xy minus y square by 2. I'm going to put limit 0 to x and dx. So once you have done all this one, I can say that now y is my integration variable. Y was my integration variable. So I'm going to replace y by x. So this will become 3x and 3y is 0. There is a 0. I am not going to take it. X into x will become x square. Do not try to put x square by 2. Just we are replacing x. It will be 0. And again here y square is replacing by x. So y is replacing by x. Therefore this will be x square by 2 times dx. Now what you can realize over here that 0, 1, 3x minus this would be like not x square. This is x square minus x square by 2. Okay, dx. So from here you can say that okay, x square minus x square by 2 would be 3x square by 2. So I can just write 3x square by 2. I'm going to erase these guys. Okay, and I'm going to evaluate the integral like 3x square by 2 minus 3x cube over 6. 3 times 2 is 0 to 1. And what you will get that 3, 1 and 1, this is 3 by 2 minus 1 by 2. And 3 minus 1 becomes 2 by 2, which is 1. So we have used this kind of thing. And if you will do the integral using first, you have done the x and then you have done y, then what you have realized that here the integral, first you have to replace y and then 1. So there is no 0. The integral becomes a little messier because there are a lot of algebraic terms. And here, why I have chosen this? Because here both the limit is 0 and x. So when you are changing your positioning, it means that your limit also gonna change. And that is what we are talking about, that if when you are diverging from yourself from the rectangular region to the non-rectangular regions, then your limits is arbitrarily changed. So you have to always take care that how you are going to perform. So although you are you have to convenient that in the particular region bound your function is going to be continuous. Therefore in order, if you do the dx dy or dy dx, it won't going to affect, but you have the liberty. So the first thing you have to understand that if I'm going to change how your integral will take place, how the limits going to change, and you have an ultimate liberty. You can based on the problems, just like over here, that my limits are very interesting, therefore very simple, therefore I have chose to dy into dx. If somehow my limits are not convenient, then I'm going to work in dx dy. So it depends on the problem and the way you want to solve it. I'm going to give you one more example because these are very interesting one. Understood? For an example, suppose that somebody already give you this particular integral to evaluate. Something going to 0 to 2, something evaluating x square to 2x. They have already given you 4x plus 2y. This is f of x comma y and dx dy. Now whenever you want to draw this kind of thing, like just like we have drawn the base, we are not using x comma f of x comma y. You have used these limits over here. Similarly, I am going to use the same thing over here, that we are not going to care about this one. If we need to particularly show that how is the region is going to create. So what I'm going to do here, that see that this is dx, this is dy and this is dx. It's going to happen. So therefore y is equal to x square and y is equal to 2x. Okay, so here first of all I'm going to draw x comma y, and this is y is equal to x square. Y is equal to x square means that it will like this, because if you put x, y will increase. So this is y is equal to x square graph, and let me just use the different color, and you have y is equal to 2x, and if I am going to draw y equal to 2x, it will be like this. So the slope is kind of 2, so this is more steeper, therefore this is the limit over here. Now you can see that here both the curves are cutting each other. So this is how we are going to take the limits. Understood? Because here this point will give you the x and y coordinate. This is one, this is going to give you the x and y coordinate. Therefore we have seen that this is x is equal to 0 and y is equal to 0 over here. Understood? And over here we have to find out that how we can find out this one. So I know that this is y is equal to 2x square and this is y is equal to 2x, and whenever they will cut, you will see that this will be 2x is equal to 2x square. Now I'm just giving you that how we can determine that what would be the x. So I can just write here that 2x square minus 2x is equal to 0, 2 to cancel out. So I can here write t will be like this, x is equal to 0 and x is equal to 1. So it says that here your x is equal to 1, and once x is equal to 1, y becomes 2. So this limit is y is equal to, oh sorry, my bad. Here I have taken different thing, like y is equal to not 2x squared, this has to be x. So this is x square minus 2x, and I got over here, sorry, I will take x minus x2 is equal to 0. Therefore, either x is equal to 2 or either x is equal to 2. X is equal to 0, x is equal to 2. So when you have x is equal to 2, then this will become 4. Okay, and this will become 2. So you see that this is how we are having these two limits like 0 to 2 and x square comma 2x. Okay. Now you can use that from here you can easily find out what is the integral, and we can also change it. Now for the thing is that what we are going to imply here, they say that first you have to take the integral in dy for particular x, then we are just going from here to here. So the limit is like this, y is equal to x square, and then there is a above limit dx you can see over here, and then you have to stretch from 0 to x. Okay. Now once you can now you can also do this particular thing, you can change this whole argument like this. For an example, I want to choose that this is 4x plus 2, and I want to choose that okay, first of all I'm going to do dx and then I'm going to do dy. Okay, so how we can change this particular limit? So I can say that okay, what we can do, that since this is the bounding curve, okay, x comma y is equal to x square like this, and this is 2x, this is x square and this is 2x. Now since I am considering dx, therefore I have to go at some constant y, I have to take the integral like this. So here you can see that the first thing is that it is cutting the 2x line. So over here I have to write what? First of all, they were already given that y is equal to 2x, therefore I can just say that x is equal to y by 2, because here I have to give like x is equal to y by 2. And another curve is just x square. So here we had y is equal to x square, so x is equal to square root of y. So the second limit will be square root of y. And now since we are going from here to here, and we are already seen that when your limit, first lower limit is 0 and the upper limit is when you had x is equal to 2, y becomes 0 to 4. So this is how we can change the limits from this guy to this guy. So in the next video we are going to determine that how to evaluate the different kinds of problems. So in the later on video I'm going to focus more on problems, and then we are going to start with double integral in case of polar coordinate, and then we are going to introduce the 3D coordinate or three-dimensional integrals like 3D integrals, volumetric integrals, and so on. So this kind of integral is very interesting and it help you. So where is the application of this particular type of integral? It will come when you will solve the classical mechanics. For an example, if you want to solve the orbital equations, because there is a lot of perturbation, because suppose you want to find the orbit of Earth around the sun, and this orbit of Earth will have some influence of the because of the Jupiter as well as the moon. So there is some kind of elliptical kind of, it is not a circular, it is not perfectly circular, it is ellipse. And there you have to, in order to find the distance or in order to find the trajectory of this orbit, you have to use the double integral kind of thing. So this is called is the elliptical kind of integrals, where you have to find the area or the volume of everything and so on, so forth. And from there you can use this kind of trick to do the integrals, and where this kind of integral is become very handy, that if you know how to plot the integral double integrals, then you can easily find it out. And if you don't know the double integral, then it is going to be very hectic job. So I hope this video is going to help you. Therefore, please subscribe and share to your friends. We will meet in the next video, and I will try to upload as much frequently as I can. And I'm going to also take the IIT JAM problems, and I'm going to give you the glimpse that how these problems or how this concept can be applied to IIT JAM problems, and then you can get into your PhD also. Thank you very much. This is Saddam Cap signing out.